In lesson 2, we're trying to figure out where the gas is coming from. This is a 2-day lesson, and we have a few investigations that we're doing. Where we left off, we realized we had some competing ideas about where that gas was coming from. Students might think it's trapped in that bath bomb, and other people are not sure where it came from. So we start by revisiting the class consensus model. If you remember, it looks something like this. We've got the different places in time and portions of the investigation. So the bath bomb, the water, the gas, and then sample of the liquid when the bath bomb was in that liquid. And so we revisit this. And then we are going to consider the questions we had and use our driving question board. And then we decide to look closely at the bath bombs using a hand lens. Here is the slide that goes with that. So little directions to the students. Work with your partner, use your hand lens to closely look inside the bath bomb and talk about what you see. So we're starting to have kids talk about what they see that is solid in the bath bomb. And then we share out and we review and record some ideas we figured out about gases in earlier units. Now, this is a great check for understanding. If your students are not familiar of gases, liquids, and solids and that they're all matter, this might be a moment where you need to do a little supplemental addition to bring them up to speed on this. There are many teachers that do the modeling with the particles of gases, liquids, and solids to show how compact the solids are compared to the gases. And so this is a nice modeling exercise that can kind of get the students up to speed with this, which is a prerequisite to doing the models. And that matter has a mass and it takes up space, and matter is made of particles. So these are what we call key model ideas. Now, they should come in with all of these ideas. And if not, this is your opportunity to kind of build them. Now, these key model ideas are going to come back over and over again. So don't forget what we just talked about. All right, then we decide to plan an investigation. And here's the slide to support you in that. And that is, we're going to plan an investigation to see if this claim is true. The gas is a part of the bath bomb itself. It's trapped inside. Now, some students probably will already know that this is not the case, but we still need to clarify this for students who may think this. And I know it seems like they might not think this, but there are students who will think this. So how can we investigate whether the gas is trapped inside? And what you're trying to come up with is, how do we do this? What are we going to measure? What are we going to record to give them a sense of planning? And so we're basically coming up with, we should crush the bath bomb. We should see if any gas is inside it when we crush it up. And so we crush it up. Before we do that, we discuss open and closed systems, and we add a few more ideas to our key models idea chart. And these are about open and closed systems. So you're going to go over the fact that a closed system is something with a lid on it, or it's closed and the air and the matter does not go in or out, and that the mass is going to stay the same. In an open system, there's no lid on this container or whatever we're looking at. Matter can get in or out, and mass can exchange if that happens. So we're setting them up to think about investigating using open and closed systems. Then we create a data table in our notebooks. And I will tell you, many teachers actually like to create these and have students paste them in their notebook, or sometimes they'll have some procedures that are on the slides and the data table. Almost they create a handout with this stuff. It makes it go a little bit faster. And so we need a starting mass in a closed system, an ending mass in a closed system, and then an open system, and then change in mass. So what we're trying to figure out here is, does the mass change when you crush the bath bomb? And so we're going to go through this investigation together, and we are going to figure out that the closed system did not inflate, and the closed system mass stayed the same, and the open system mass stayed the same. So we're trying to figure out, is gas a part of that bath bomb? Well, when we crushed it, no gas came out, so that would be a no. When we crushed it and it was in a closed system, the mass was the same, so no. And the open system, the mass stayed the same. And so the gas didn't leave. So this shows us that the gas is not a part of that bath bomb. Now, I would tell you the setup for this poster chart, I would probably create all of it except this right here. And if you're doing this under a DocCam, you could just make copies and pull this out. And you're just asking students to say, what does this claim mean? Does it provide evidence that gas was a part of the bath bomb? Yes or no? Give me a show of hands, give me thumbs up, give me thumbs down. And so we're going to come to the idea that, well, if the clothes bag did not inflate, there's no gas in there. So we'll make an X and it's against. Then we're going to plan a second investigation. So this is going to be another day. And it's called the bath bomb in the bottle investigation. And so what we're going to do, very similar, open system, closed system, but we're going to add water to the plastic bottle with the bath bomb. And so you don't need 8 mini bath bomb cubes, although we are supposed to use several. But this lesson uses a lot of the B recipe bath bombs. So you're going to crush them up and you're going to put some in an open system in water and then in a closed system in water. And you're going to kind of make a procedure with the students. But again, some teachers scaffold this a little bit. If your students need a lot of direction, they might write up the procedure. You do want students to feel like they're owning the planning of this. It just kind of depends on where you are in your year. If you are going to scaffold it and give them procedure, or if you're going to really have them create the procedure as a class. So now we're going to test the claim that gas is something new produced. Now this poster, I would create everything except for this column right here. And so if we observe this, and this is before we do it, we're making a prediction. If we observe this, what would it tell us with our claim? It would support that the gas is not new matter. It is new matter. It's not new matter. It is new matter. So if you have this pre-set up, you're just going to go through this with the class. And then we're going to collect some data and collect evidence to test our claim. And so this is the evidence that should be collected. Each group is going to do this investigation. You can make a chart on the board or under the DocCam or a chart paper. And you will see some inconsistencies in the mass in the closed system. The bottles aren't perfect. They do leak a little bit. Someone might get some water on the outside. So, but you can see there's a pattern here that this really doesn't change in mass. And after opening the system, there's a loss of mass. So that gas had mass. And you can hear the gas when it comes out, and look how much mass is lost when you open the cap. So this shows us that the gas is in there and it's a matter and it weighs something. Okay, so we're going to then engage in a building understandings discussion. And in the teacher editions, look for these call outs, which are key ideas. The purpose of this discussion is to develop an argument to decide between our two competing claims. So look for these ideas as you're facilitating the discussion. And they're going to share some of their evidence that I just went over. And you're going to record some ideas on a chart. Here's another chart. There's a lot of charts in this lesson. So I would say that I would probably create all of this except for this box right here. So when we combine the bath bombs and the water, the mass of the closed system stayed the same. So you're trying to say which claim it supports. And we're supporting both in both instances that the gas is not new matter. It comes from what was already there. So this is a really key idea that this gas might be new, but it comes from the matter in the bath bombs. We're going to add these highlighted ideas to our key model chart. And so we are going to add this idea. We already did all the stuff that's not highlighted. We're going to add this highlighted portion right here. So even when changes happen to the matter, no matter gets in and out, but even when changes happen, such as becoming a gas. And then we're going to scaffold a CER argument. Now, if your students have done this before, you might be able to go a little bit faster, but this is a real scaffolded approach. And so we're teaching them to use the key model ideas as the reasoning. And the claim is what answers the question, and you're going to support it with evidence, and your reasoning, your key model ideas connect that evidence to the claim. Now, there is a poster that you can create beforehand or have on your wall all the time about a CER. So I would pre-make this one as well. And then the final thing is that they're going to write individual arguments about where that gas comes from. And this is definitely something you can grade. So they're going to use the evidence and the key model ideas. Some people scaffold this even more and do the CER graphic organizer to help scaffold it even more. So there's a lot going on in lesson 2, 2 investigations and a CER. A lot is happening. Good luck.